My name is Kseniya. I'll be talking about infrastructure testing in AWS. I've been working as the QA engineer for 7 years, and I've been working over the couple last years in a company called AWS. It's located near the Mediterranean Sea in Cyprus. A couple of words about my company. I think the technologies will impress you, and the figures for the company will impress you as well. They're all presented here on the screen. So I have listed the technology, but it's not all. It's only a tenth of what we're using. Just a year ago, our company decided to work in such a way that using certain components, we assemble a unique product for the customer, and each customer will be able to use such a product. That's why we had to enable infrastructure application work with just a press of a button. We started to think how this task could be solved, and this could have been done by different solutions, and we decided to use the application of AWS service. Please raise up your hands, those who know what it is. Right, this is the Amazon Web Services. It's a provider of cloud servers. You can roll out your infrastructure immediately in this cloud service. We chose this one because it is expensive to roll out the infrastructure on our own facility. It was cheaper to rent and use the external one, and that's why we decided to represent the infrastructure as a code. I'll tell you about this approach. So this implies that we create infrastructure and manage it with the support of the physical configuration, but not using the code. Somehow, with certain actions, the system is rolled out in the AWS, and the infrastructure is created there. Infrastructure can be scaled up for each customer. It could be rolled out for each customer quite fast, and we could have several infrastructure facilities. This gave us a possibility to save deployment time. You just press the button and infrastructure is becoming available. So it's easy to delete it. Once infrastructure testing is completed and the infrastructure is no longer needed, you just can delete it, and you do not pay any longer for this. So all this becomes really good because it saves money and minimizes the risks. And you know, when you describe the infrastructure via code, it's kind of risky, because if something goes wrong, you have to rewrite it. But if you only correct one mistake, this mistake is no longer repeated. It's being deleted all over the infrastructure. What is infrastructure testing? This is a testing of the infrastructure for its compliance to the architectural requirements, configurational requirements, as well as testing for availability of all parameters in your resources. It also tests the links between the resources and tests its usability and performance. Infrastructure testing is not environmental testing. You can have a provider, you can have your own internal services, but this is not environmental testing. This is also not tools testing. In our case, we use such tools as Terraform, Ansible, Puppet. But we do not test tools, and infrastructure testing is not functionality testing. You may ask, why do we need to test infrastructure? We perform so many tests. Why we need to do any additional ones? But I think that infrastructure should be paid attention to. In the same way as application have to comply with the functional requirements, infrastructure has to comply with the uniform architectural requirements. There are other reasons why infrastructure testing is needed, and this is because we can detect problems at the early stage. Such problems can be detected prior to rolling out infrastructure. So you see, we still can do it for free and already find certain mistakes. An advantage is that we can test its safety as well as control expenses, control the resources consumption, amount of resources used, as well as compare the prices offered by a provider. Another advantage is that we can control configuration in a half-manual mode. It is not good when somebody who has access to the infrastructure can manually access it, make some amendments and configuration there, but it will not remain in a Git and nobody will learn that it has been done and this will be forgotten. All the problems which I have listed could be solved with the help of the infrastructure testing pyramid. But I may shock you now, but it's not a pyramid, it's actually a square which has 3 levels: low, mid and high. Low level, just like in a usual pyramid, is the unit test when you check the syntaxes of the infrastructure and code style. In our particular case, we only use syntaxes and code style, but we are moving forward to unit tests. The instruments applied are Robocop and Lean. Low-level tested is necessary to enable us to detect the problems very fast. To do this test, you do not need a network connection, and that's why we do not pay for the resources. It also gives us a chance to unify our resources, stick to the housekeeping, and have all our resources in a neat and tight manner. Mid-level testing is the largest. At this level, we test all the resources and their parameters, we test all the attributes and links in between, as well as security settings. At this stage, we do most of the tests. They are rolled out in the infrastructure which is built, which is launched. But this test can be done both on a stand testing and on a prod. The tool used for this is InSpec. I'll tell you more about this tool later. Mid-level testing helps us to get rid of the configurational errors in the infrastructure. We also check here the safety settings, control expenses, to save money, and to select best resources to solve the tasks required by the infrastructure. Mid-level testing allows us to control configuration in a semi-manual mode. We chose InSpec tool because this is a very simple framework to perform infrastructure testing. It's written in Ruby. It has a couple of advantages. Among them, documentation is available and it's easy to use it, so it has a lower entry threshold. It has a wide, extensive library of resources, and it's easy to integrate with AWS Ruby SDK. However, you know that providers are developing very fast and the library will never be complete. Frameworks are not developing in the same fast way, and that's why we sometimes have to search for bypasses, how to reach on that. And that's a disadvantage. Another disadvantage is that it's more suitable for a statical infrastructure. It's quite often we access the resource, send a request for an ID, and the resource ID changes every time after restart of the resource or after making changes to certain parameters. An example to this, please have a look. In this example, we test their existence over an instance. The syntaxes is very similar to the English language syntaxes, so it is easy to read. Here, we describe a request to the EC2 instance, and it is checked for its existence. This test seems to be quite simple. In example number 2, you can see the test suite. Here we describe 4 tests. Here the request is sent to the EC2 instance, but we do not use ID. In this particular case, we make a request to a name. And after 4 tests, we check that it's already running. It's a tag key name, resource value. Also, we test resource name and public ID. High-level test is characterized by high load and stress. Load test is combined with configuration test, and we start to focus more on the sources of the infrastructure and whether they are used in the best optimal way. A tool used here is just monitoring, but it saves us and it helps us. High-level testing is needed to control and measure the system productivity, to support best configuration settings, and to combine the resources in the best way without spending too much money on that. Also, high-level testing is needed to control the expenses at all levels. I'll tell you how we launch the test. First, we launch the pipeline. After that, we form low-level tests, such as code style and syntaxes test check. Next, we go for build code Terraform, and the infrastructure is moved to WCA, and then we perform mid-tests on the infrastructure. So, to sum it up, I can say that sometimes it's not needed to test infrastructure at all cases, but if you do it, you have a possibility to control safety, and your security team will be thankful that you are doing this. Also, it gives you a chance and possibility to control expenses, which is good for the managers and for the owners of the company. They will say thank you to you, and this affects performance. Now, the users will be grateful if you do it, and you will be able to keep your users' loyalty. You might be interested more in the infrastructure testing. Unfortunately, the documentation or resources where you may learn something about it is limited. Here, I've collected some of the links, some of the names where you could read about infrastructure testing. These are the companies and blocks of companies who are performing this. The links are here. Also, I propose to read a book by O'Reilly, which is on infrastructure testing. There's a chapter devoted to this. It's quite big. Sometimes you can read a lot on the Medium or in the Harbor, including infrastructure testing. Basically, that's it. These are the contact details. Please, your questions. Good afternoon. Could you tell if you really make developers work with these functionalities and be responsible for that? Well, DevOps sometimes do it, yes, basically yes. They also write tests. But how do you share their scope of work? Our team is cross-functional, which means everyone does everything. Thank you. I have a question about the types of tests. If I understand you correctly, the key idea of what you have explained us is that the test check that infrastructure works and is an operation. Do you emulate certain complex situations, for instance, new network appeared? And do you check how infrastructure behaves after certain accidents? Yes, there's a test. There are tests to check what happens if an instance falls down, then the second instance is supposed to raise. Also, we do set up for alerting and for alerts monitoring. Well, there are notifications if something happens. Good afternoon, my name is Olga. How do you assess the efficiency of such tests? And how often do you detect bugs or failures or problems? And at all level of testing, do you usually find such things? Unfortunately, we do not have yet metrics to evaluate the efficiency. We sometimes do detect bugs. So I think detecting a bug is also an efficiency indicator. Presentation. Tell me, at which point of time do you start developing infrastructure tests? Maybe the testers write functional tests. Which stage do you start writing this testing? We write this test at the point of time when we write the infrastructure, when we develop the infrastructure, because this has to be discussed with the developers and in parallel create infrastructure and create infrastructure tests. Thank you for your question. Thank you for the talk, it was interesting. Where do you get their configurations from? Where do you get these block configurations from? Because you actually have to control how you get them. I didn't get your question, sorry. Oh, please apologize. Okay, so you meant where do you get the semi-manual configurations from? And why you use them? Well, you see, sometimes the customer would like to have the solution or information right now, but it takes time to develop the infrastructure. I have a question about control of expenses. Do you control expenses for infrastructure test developing? And what's the outcome? Is there any profit in that? My second question is whether AWS works stably after you change from your environment to the AWS environment. Does your service perform stably if you roll it up in the AWS server? So I'd like to check how it works. Does it work in a stable mode? And how you control the expenses? There is no difference in stability, by the way, as regards the costs control. It's hard to assess. Because if you have server infrastructure, it means it's already available. And these are one-time costs, one-time investments. But if you are using the AWS, you have to pay a monthly fee. And probably in the short-term run, it's cheaper, but it's a long-term run, it's much more expensive. The profit in writing and developing infrastructure tests is the second question. Well, actually, these infrastructure tests are needed not, but even without reading the pricing, you may just, by accident, spend a lot of money. That is why it is necessary to develop tests for infrastructure testing to reduce the errors. Do you have any idea how much a bug cost? I mean, a bug which was detected during the infrastructure test. Oh, thank you very much. Our time is out. Please choose the report, the question which you like most of all. Please raise up your hands, those who asked questions. I liked, I guess, the last question because it gives food for thought. Thank you. That's it.